Riak and Node, best served with HTTP. Philipp, great that you are here.
Thanks.
Have fun.
Okay. Okay, hi. Today I'm gonna talk about, like you said, Riak and Node.js mainly. So I don't know if you can read this, but what you can derive from this, Riak is a NoSQL database. It says like, do you have any experience in SQL? No, then you're an expert in NoSQL. What is Riak? Well, it's NoSQL. So and in this family, it's mainly it's a key value store. You can dump data in under a key and get it back. So in the first slide, I'm gonna do a little introduction to Riak itself. And the first part is going to be about Riak being a Dynamo store. So who's heard of Dynamo? Or read the paper there was like some years ago by Amazon described their approach to data storage and so on. Well, okay, since it's not so many, there are three really important features of it, and I'm going to introduce them real quick with my awesome drawing skills. It's really hard to find a program to just do random drawing, which doesn't suck. I didn't find one. This is what come out of it. Okay, so, well, it's a key value store. So what you do, you can put the key foo in the store, and it's going to end up in some place. So what's this place? If you look at it's Riak is organized as a ring of slices of key space. So in this case, I draw it like, okay, there are 64 slices, and for example, if I want to store foo, the key gets hashed in some way and gets assigned to one of those slices, in this case 2, and the key ends up there. So what I can do with that is I can actually really easily distribute my data across multiple machines. So if I look at this, I can say like, okay, I got those 5 machines and I take slice 1 to A, slice 2 to B, and so on. And well, even so I have 64 slices, I can like pretty evenly distribute them across 5 machines. So this is nice, but well, if I store a key in there and it ends up on one machine and this machine dies, my data is gone. And also if it's not reachable for some reason, for some time, it's also, well, not available. So what we can do is, okay, when we store this key in slice 2, the machine also decides, like, okay, I'm going to replicate this key to 3 and 4. So if 3 and 4 are on different machines, then my data will still be there even though the machine for number 2 died. So this is actually the fault tolerancy, which is the third most important part. It's like you remember, okay, you store it there, it gets replicated, and if you look at it, there are the machines are organized that each following slice will be on a different real machine. So if one machine dies and the data is replicated on the 2 next slices, then it will actually most certainly end up on, well, in this case, 3 different machines. In most cases, it will end up on 3 different machines. So if this happens, like machine 2 or machine B dies, and I try to get out the data, I still can because it's also on 3 and 4. And if the ring realizes that, it will also start replicating it on more machines. So if 3 machines die, it will hopefully still be there. Okay, but what does it actually give you? Why did Amazon do this? Well, they did it for scaling because they have like real huge data sets. And so they decided, okay, it would be awesome if you just add more machines and we get higher performance. Though this is what it's really about. So if you add more machines, you get obviously more storage because you have more RAM and more disk space. You get more throughput because you will ask different machines, and probably lower latency because you will ask different machines for following keys, so they will distribute their load really good. So what's nice about Riak for our use case currently it's really web friendly. So the main interface to it is just simple HTTP. The value you store under the key is completely irrelevant, so we use JSON for that. Other people just use plain text. For example, I talked to the guys from eBay Kleinanzeigen. They just dump whole email conversations in there. And, well, it supports JavaScript functions. That's what I'm going to talk about later. So when to use it, we probably can't see this, but this is I hoped it would be bigger. This was a comic drawn by Eric Redmond. It's like, okay, you've got all those great databases. What should we pick? And somewhere in between, there's actually Riak, and it's for high availability, actually. So this is actually this is really important for Riak itself. It's like if you want to have a data store which is highly available, Riak is a great choice. So okay, but if we got any data, we need to, well, organize it in some way, because just key value probably doesn't cut it in a lot of cases, at least. But basically, the basic organization is simple. You've got keys identifying objects. Objects can have metadata, and objects are grouped into buckets, which just basically provide more metadata for those keys. So what can we do this? For example, Riak provides the way to link link keys or documents stored behind keys. So you can actually say like, okay, I got a user and he also owns a car, so I put in a link towards the document for the car, and if I want to get the car out, I can do get the user link walk to car, and I will get the car back, which is really nice because you can do like basic structures in there. Also, it supports secondary indexes, which you can basically think of as tags, so you can tag any value in the store with whatever you like. And you can also do like range queries. For example, you can could tag like train rides for, okay, I only train rides with their price, and then you can say, I only want train rides which are cheaper than 100 euros. You could do that with that. And it also supports timeout. So if you've got a document and say like, for example, a session, you could store it in there and the database will handle the timeout. So if you request the document after the timeout, it will just return you 404 and say like, oh, there is no document. So you can actually don't have to like take care of a whole timeout thing in code yourself. The thing really is Riak understands HTTP, and it is built around the concept of HTTP. So what we can actually do is interact with it just with basic curl from the command line. For example, I did this, like store a JSON document, which is already like, okay, it understands the content type header, and it will also serve it back, so you know what the content type is, and you can just store any data in there. Well, then of course you can query the document to get it back. And, well, really everything can be done via HTTP in this case. So if you actually want to set some properties of, in this case, a bucket, you can just put the properties object, and nval in this case would be the replication factor. So how many times should any value I put into this bucket be replicated? And in this case, I would set this to 5. Yeah. And you can do really complex things, but yeah, I'm not going to go into details here because I'm going to describe it in JavaScript code, real JavaScript code later. But you could actually just do, like in this case, a map introduce via curl. But okay, since it's a JavaScript user group and I mainly use Riak from JavaScript, or actually Node, let's talk about using Riak from Node. Actually, the nice thing is we can have JavaScript pretty much all the way down. Since it's like, okay, we got a driver which is written in JavaScript and doing, well, writing a JavaScript, writing a driver in Node which just has to speak HTTP is actually pretty simple. So the driver code is also for React.js. The driver code is really readable, and I think it's like probably 500 lines of code or something, and it handles a whole bunch of stuff. So what you do is you get the client, and then you can interact with it like with most other databases. You do like store it, and you will get back values. You can retrieve values. In this case, you will get it back, and you will also get back this meta object, which is in case of Riak really important because it holds the metadata for the stuff you put in there. Which is also things like a logical clock, which tells you in which logical order this document has changed. But you can't really interpret it in your code because it's a hashed value. But this is the way Riak will determine if it got like conflicts, and it can resolve conflicts based on this and everything else. So if you interact with it, it's really important to, if you get a so-called vector clock, you have to pass it back, or things will go really nuts and get really confusing, because you will get back, you will query the data store, and you will get back, instead of expected one object, you will get back an array of X objects, because it will give you back every conflicting thing you put in. So if, for example, you stored pizza with cheese under the key pizza, and then you stored with bacon and with whatever, and you didn't like pass the vector clock each time, you will get back an array of the 3 data values actually. So you can like resolve it yourself, because Riak didn't know any resolving strategy in this case, so it will just give you back every value. You could overwrite this, but it's actually a pretty sane default. So, and what I'm going to go more in detail here, it's map and reduce. I think most of you will be familiar with basic map and reduce, right? Or who has used map and reduce kind of stuff? Okay, nice. Okay, the basic concept is really simple. You do a request. The request contains some mapping function, which is executed on every node it can. The node will pass back the data, and this in this case would be like a coordinator node, and it will reduce the data down. I will show this in later slides now. So Riak actually supports this really simple. What you actually have to do is you provide a set of keys, where the mapping function should be applied over. Then you have, of course, to provide a mapping function. And if you want to, this is optional, you have to provide a reduce function. So what does it look like? Okay. Still remember, we got our database from before. We initialize a new map and reduce, and we add a certain amount of keys. So in this case, I would have just added like foos, which was the bucket I created earlier. And in this case, this would like map over every key which is in this bucket, which is in most cases not really a sane thing to do, because if you have like 10 million keys in this bucket, this will take a long time. So what you can actually do to make this better, you can apply key filters. You say like, okay, I want my key to be tokenized by an underscore in this case, and I want to get back the first element of this tokenization, of this array, which will be the key afterwards. Then I apply a lower function, and then I match on this result, which will actually give me back like every key which starts with foo in this case. And this in this case would be this would be the keys this function maps over. You can do different stuff as well. You can, for example, say like, remember from the beginning, secondary indices, you can say, okay, please map over every object indexed like this. For example, to get back to your earlier one, it's like map over every train ride with a price lower than 100 and do whatever with it. Okay. So, for example, if a really simple mapping function in this case would be Riak.mapValueJSON, which should actually be value. No, it's value. JSON, which would instead of giving you back the well, it would get back, instead of giving you back just the keys in the end, it would actually give you back the all the value of those documents, because it extracts the JSON. In this case, if you have stored JSON, it will extract the JSON, and the keep true will say, okay, don't drop it after the query, which is actually true by default. And then you apply run, and it will give you back. Well, in this case, it's kind of a stupid query because it will give you back every value contained in the bucket foo, which is, well, probably not really that useful. But you can also do more complex stuff, because Riak in this case understands JavaScript functions. You can just pass a JavaScript function to map, and it will do things, whatever you say it will do. It has this built-in like global Riak, which gives you some predefined functions, for example, to extract JSON values in this case. Yeah, and it will. And you have to return an array from this, because it will. You will have to combine it later probably. So we have to return an array. So in this case, I say, okay, if the value is something, in this case foo, then return it. Otherwise, just drop the value. For this would be like a simple filter, for example. Okay. So now towards reduce. Well, what we get back from this mapping function is, like we said before, it's probably some JSON value or whatever, and you can now apply well, a function on the final node we saw to reduce this down to something. For example, this would be reducing it to a count. So we still have to return an array, like we have to do in every case, but in this case we return an array of the values. In this case would be everything returned from the mapping function, and values.length is of course the length of those, so you will have implemented a kind of stupid count. But you can also do, like I said, you can do like anything you want. For example, you could do count it if something is set to true in this value. It's a really powerful mechanism. You should watch out to have like not really overly complex functions in there, because like we realized it will get slow, and if you run like really complex map and reduce queries on the database, your database will of course have to execute this, and it will be blocked during this time because it has to do stuff. But it's actually in Riak, it's actually a valid query mode to map over a certain amount of, well, a small amount of keys and extract further stuff out of it, which is really nice. Well, this was it for my talk for right now. And if you want to learn more about it, there's a new meetup set up. It's Riak in München. It's well, it's probably next time at the IT-Agenten. And also, if you want to know more about the basics of how Riak works, there's the little riakbook.com, which is actually free. And it explains like the theory part, not using it, but just explains more of the theory part. To get more into detail, we are currently using this at Pro7, like I said before. And so far, it seems to be working out really great. So I've been playing with Riak for quite some time now, and this seeing like in a bigger project, it scales really well, and it seems to, and it's really easy on the ops, which is a nice thing. Okay, thank you. So if any questions? Yeah.
How is data stored? Is it just on disk, or say you have a giant file? Will it like choke the database?
There are actually you can change the backend on how it's stored. So mainly there are three different ways. You can either store it just in memory, or you can store it in it's called bitcask, which is like a really simple key value store, which keeps the keys in memory, but stores the data on disk, so it can really quickly retrieve that. And also there's, if you're familiar with, there's LevelDB from Google. You can also use this as a backend, which also supports like more advanced query modes. And yeah, mainly the data, it's built for huge data sets. So you normally, if you use it like in complete normal mode, you should not exceed probably like 2 megabytes per value stored, because it will it will generate a lot of network traffic and it will slow everything down. But there is also a project which is called Riak CS, which completely mimics the Amazon's S3 API. So you can store however large objects you want in there, and will internally chunk everything. We are using this currently for a client for testing purposes, because it's really nice to not have to doing tests to do a request to Amazon S3 every time, or every developer has to have his own S3 setup. But we can actually just do a Vagrant box which has Riak CS running, and it completely behaves like S3. This.
A second question.
Yeah, sure.
You said there's a ring of basically of servers, or a distributed hash, I guess.
Yeah.
So how do you know which? So there's no master. So how do you know where to connect? So I want to query the Riak. So
you can connect.
How do I call homes?
You can connect to any node of those, and it will ask the right one afterwards. It does this completely internally. What a lot of people actually do is, since it's speaking basic HTTP and it's also like really close to the standard of HTTP, you can put like a simple load balancer in front of it. You can use like Nginx and load balancing over everyone. And for example, I think it was also at eBay, they are putting a varnish in front, so to make even quicker access to the things. So it's really nice this way. Yeah.
Yeah, maybe I missed it, but I'm asking, so if the value is like a document, maybe like in a MongoDB NoSQL document, yeah, and then this is like JSON, with properties, and I want my query on the properties inside this value. Is this possible?
It's not like Mongo is a document store which really knows something about the document stored. Riak just stores whatever you give it. And you can access the document if you do like a map and reduce in this case. You could access the data stored, but this is not the normal way. Normally you would just like tag objects with secondary index. So you tag objects and store in the metadata of the object, not the object itself in this case, and you query it this way.
This is not a basic. For example, I want to build a CRUD application, a basic CRUD application.
Yeah.
I think it's not the kind of database for that, because how can I build basic data structures? Like what we learned in relational databases like SQL, and you're organizing your data, and it seems like a new pattern or something special, which is not common.
Yeah, it's a different pattern, of course. You have to model your data to fit this way of storing it.
And if you have files like blobs, or I don't know how to call it, but if you say you want to proceed like video files or so, I think this is the best way for managing this stuff.
Classic
data structure.
Well, it depends. I mean, for example, currently the project I'm working on, we are doing like user profile management in there. And the user profile is mainly a set of JSON documents, which can be retrieved. If you want to store, like I said, if you want to store images, you can use an extension to Riak, which is Riak CS. But it really depends on how you model your data. If you can model it in a key value way, then it's really good. And there's actually a lot of stuff you can model in a key value way. For example, Xing is using it currently to model their, if you look at the front page, not the front page, if you look at your page on Xing, you see like this activity stream you have. And this is actually completely served from Riak. This is like, they have documents which are chunks of the stream, and those documents reference the sub-documents, which is like this person liked whatever. And then they did kind of, yeah, they pre-compute the stuff and put it in there. So what you have to get used to is like not trying to do everything in one query, but it's completely feasible to do like 2 or 3 queries to get back, for example, a chunk of the stream, because you can be those key value queries are really quick, like they would be in like any database. If I do a key value query in MySQL, it's crazy fast, and the same way is here. So you can actually do a lot of queries and still get really good performance.
And it's stable, I guess.
And it scales out. So yeah, and stable as well. Yeah.
Also a question, you said that if there is a node failure, then you have replication and then
Yeah.
no data is lost. But if you run MapReduce jobs all the time and a node fails, what happens to the jobs that are running during node failure?
Actually, I'm not completely sure because I didn't experience that yet.
I'm asking because
Well-
this is such a great feature of Hadoop that the jobs run again on the backups and you
Yeah,
analyze it and get the result.
I think in this case it's not such a huge problem, because it will try to ask. You have like it's actually defined by 3 properties. You have a read count, you have a write count, and an n value. So the n value is the amount of distribution you want to have. So you can say like, okay, distribute it on 5 machines. The write value is like, okay, don't return a success for the write unless it's stored on X of those, unless X responded with yes. And the read value is how many responses I want for a read to be successful. So if the bucket you do a map over says like, okay, I want a read value of, for example, 3 for my keys, then it will ask 3 of the replicas for this. So in this case, if a node fails, then you will get back 2 valid responses and 1 failed one, and you will still have your complete data set. If 3 fail, then you're out of luck. But in this case, I would say just don't run with read 1, and you should probably be good to go. Yeah.
So the value of a key, do I have it to read it and change it and write it at once, or is it possible to just append content to a key?
You always have to read it and write it back, because Riak knows nothing about the stuff you store in. So you can't just do it.
There's no mode with just appending or stuff?
No, not that I know of, actually. But they are currently, like the new version, they are expanding in the data types kind of way, also for the conflict resolving. So for example, they are currently implementing sets in Riak, which do their conflict resolving themselves, and then you can add elements to the set, which would be kind of like append in this case. Yeah.
So when the communication is based on HTTP, so does Riak have some caching features you can configure?
No, but you can put a simple HTTP cache in front. Or you can, like, if you need more performance, there are other ways of, there's also a protocol buffers interface, which is quicker, somewhat quicker. But I think just HTTP is just the nicest and well-known interface. So, and I didn't hear of any like performance issues with it really. So yeah, probably just put a simple HTTP cache in front and you'll be good to go. Yeah.
If I see it correctly, you always have to send JSON. So this means when you want to store binary data, you always have to encode it to an SVG.
No, you can store everything. My examples were JSON, just because you can like do stuff with JSON.
I mean the
but
format when you talk with Riak.
Well, it's just data you put in. It depends on, it stores the content type you pass to it, but it will, and it will also return this content type. But you could do whatever, binary or whatever you want to store. You can just dump that in there and it doesn't care. It's just you have to give it a key, which is a string, and then the value doesn't matter. The only thing, like, you have to communicate in JSON for configuration. There's a configuration properties object. It just takes JSON, but, well, it's for configuration. It uses JSON, but not for any other values are not set. Yeah.
Riak itself written in Node?
No, it's written in Erlang. So it embeds the a JavaScript runtime. I think also it's not the V8 as far as I remember, but yeah, it's a pretty good JavaScript runtime. They embed it, but Riak itself is not written in JavaScript. Yeah.
For the reduce function, you define a filter, and are there any if the filter is too complex, you told, then probably your database will not answer. Is there any timeout?
Well, you can configure a timeout. Normally, it's pretty long, but the thing is, like, it will respond, but it will like create a lot of load on your database if you do really complex processing there, and it will like move out of the okay, I want to do like real-time kind of queries, like, okay, I got my website which requests some data, and if you do like a really complex map and reduce job and the map and reduce job takes 20 seconds, well, then you won't get back data before 20 seconds. So it's not like great for live data then. That's what I meant. But you can do anything you want in there. I mean, the only thing is it expects that you return an array. That's the thing. You get past an array and you have to return an array. Besides, it's just JavaScript.
So any further questions? Thank you, Philipp, for your great talk.
Thanks.